Today's topic is E versus K diagram and Brillouin zones. An electron moving in lattice of periodic potential can have the energy values between allowed regions and allowed zones. They are called Brillouin zones, and they are studied by making the E versus K diagrams. We know from chronic penny model the condition for permissible energy states or allowed energy states is given by P sine alpha A upon alpha A plus cos alpha A equal to cos Ka. In this equation, if alpha A equal to plus minus n pi, then this term will be 0, sin alpha will be 0, and first term will be 0. So we have cos alpha A equal to cos Ka, or you can say alpha equal to K. So K will have the values plus minus n pi by A. So we can say that right side of this equation will have the values between plus minus 1 if K is equal to plus minus n pi by A. So this K gives the discontinuity in E versus K diagram. If we plot energy values versus K is wave number or propagation constant. Propagation constants, and its value is also K equal to 2 pi by lambda. So from this equation, right hand side will take the value plus minus 1 only if K equal to plus minus n pi by A. So this K will give the discontinuities in the E versus K diagram. If n equal to 1, 2, 3 and so on, then K will be plus minus pi by A, plus minus 2 pi by A, plus minus 3 pi by A, and so on. We know for a free particle, energy values are E equal to h cut square K square upon 2m. If we plot E versus K, then this will give a parabola. Now, suppose this is A and this is K, and if we plot this free particle, energy for free particle versus K, then we get this parabola. This is for free particle case. When there is no discontinuity, all the values are allowed. Okay. Now, we know in this case, in the case of chronic penning model, the discontinuities are at plus minus A, plus minus 2 pi by and so on. So let this is 0, this is plus pi by A, here is minus pi by A, 2 pi by A, 3 pi by A, 4 pi by A, 5 pi by A and so on. So similarly, minus 2 pi by A, minus 3 pi by A, minus 4 pi by A, minus 5 pi by A and so on. We have drawn lines at discontinuities. Okay, so for K equal to plus minus pi by A, we have our curve diagram is continuous between minus pi by A to plus pi by A. Okay, so this for the region for which the diagram is continuous, that is called Brillouin zone. So this is our first Brillouin zone. Brillouin zone. Or you can say this is first allowed band. Okay. Now for second region, n equal to discontinuity is at 2 pi by plus minus 2 pi by here. So like this. Okay. So you can show here for this region there is discontinuity. Okay, in this region the electron is not allowed. Okay, so in this region electron is allowed. Electron is allowed for this region. So this is allowed band. Allowed band. For these energy values electron is allowed, and for these energy values electron is not allowed. So this band is not allowed band or forbidden band. Forbidden band. Again, so for this, again, the E versus K diagram is continuous from here to here. So this is allowed band. This is allowed. Again, discontinuity occurs at 3 pi by A and minus 3 pi by A. So we have for second reason, and for third reason we have like this. Okay. Similarly, we can make in negative side. Okay. Again, this is allowed band and this is not allowed. This is allowed. Okay. So you can see clearly here that allowed bands are separated by some not allowed band. They are called forbidden bands. Okay. The electron will be not allowed here. So we can draw a conclusion from this E versus K diagram that number one, allowed bands are separated by not allowed band, that is forbidden bands, and the E versus K diagram will have the discontinuities at K equal to plus minus n pi by A. K equal to plus minus n pi by A, and n can take the values n equal to plus 1, 2, 3 and so on. So we have the allowed bands separated by not allowed band. This is also allowed band. Allowed. This is not allowed. Again, this is allowed. Okay. And second point is, you can see clearly that width of this allowed band is increasing as the value of K is increasing. Width of the band, allowed band, increases as K increases. Okay. First point was allowed bands are separated by forbidden bands. Bands at plus minus n pi by a. And here n can take values 1, 2, 3 and so on. And as the barrier strength, measure of barrier strength P decreases or approaches to 0, then this discontinuities will extend to a parabolic form. Okay, then that will be the case of free particles, where there is no forbidden gap. Okay, now I have shown that the region which is extended from minus pi by a to plus pi by a, this is first Brillouin zone. Okay, the energy values are allowed between this region, so this is called first Brillouin zone. And energy values taken between these two regions, minus pi by a to minus 2 pi by a and plus pi by a to 2 pi by a, these are second region, and these are called second Brillouin zones. Second Brillouin zones. And so on. Third Brillouin zone will exist between minus 2 pi by a to minus 3 pi by a and plus 2 pi by a to 3 pi by a. So first Brillouin zone is first zone, minus pi by a to plus pi by a. Second, minus pi by a to minus 2 pi by a and pi by a to 2 pi by a. And similarly the third Brillouin zone and so on. Now we can draw the Brillouin zone in one dimension. So this is the line having the values of k. So 0, pi by a, 2 pi by a, 3 pi by a, 4 pi by a and so on. Similarly on left side, minus pi by a, minus 2 pi by a, minus 3 pi by a, minus 4 pi by a and so on. So first Brillouin zone as discussed is between minus pi by a to plus pi by a. This is first Brillouin zone. So first zone is in one dimension. This is minus pi by a to plus pi by a. The region lying between minus pi by a to plus pi by a. This is first zone. And second zone is this is second zone. So second zone lies between minus 2 pi by a to minus pi by a and plus pi by a to 2 pi by a. Similarly, the third Brillouin zone is this is third. Third lies between minus pi by a to minus 3 pi by a and 2 pi by a to 3 pi by a. So third zone is minus 2 pi by a to minus 3 pi by a and plus 2 pi by a to plus 3 pi by a. Now to draw the Brillouin zones in two dimension, let us consider the motion of the electron in two-dimensional lattice, and that is specified by, that is described by wave number k. Now let the wave number k is divided into two components, kx and ky in two dimension. So this is along x direction, this is along y direction, kx and ky. So kx will take the values plus minus pi by a and ky equal to plus minus pi by a. Now for one dimension, equation of continuity is plus minus n pi by a, and for two dimension it will be kx into n1 plus ky into n2 equal to plus minus pi by a n1 square plus n2 square. Now these n1 and n2 are the integer corresponding to the axis. So n1 is corresponding to x-axis and n2 is corresponding to y-axis. Okay. Now we want to sketch the first zone in two dimension. First Brillouin zone in two dimension. For first zone in two dimension, n1 and n2 can take the values plus minus 1 or 0. Let n1 equal to plus minus 1 and n2 equal to 0. So from number 2 we have kx equal to plus minus pi by a. And when n1 equal to 0 and n2 equal to plus minus 1, then we have from this equation ky equal to plus minus pi by a. So if we draw these two conditions here, then we will get a square minus pi by a. This is plus pi by a. So we will have a square from these equations like this. So this is our first Brillouin zone. This is first zone, first Brillouin zone. Okay. Now we will sketch the second Brillouin zone. N1 and N2 will take the values plus minus 1. Let N1 equal to plus 1 and N2 also plus 1. Then this condition will become kx plus ky equal to 2 pi by a. When n1 equal to plus 1 and n2 equal to minus 1, then we have kx minus ky equal to 2 pi by a. Again, when n1 equal to minus 1 and n2 equal to plus 1, then we have minus kx plus ky equal to 2 pi by a. And again, when n1 equal to minus 1 and n2 also equal to minus 1, then we have minus kx minus ky equal to 2 pi by a. So these are four equations. These set of four equations will describe the lines which are at 45 degree to kx and ky axis. So we have four lines from these four equations. These are inclined at 45 degree to x and kx and ky axis. Okay, so we have second Brillouin zone. So we have second Brillouin zone between ABCD and EF GH points. So this is by straight lines. This is second zone. Second Brillouin zone is shown by straight lines, these lines. Okay, and this is the region between ABCD and EFGH. Okay, now third Brillouin zone in two dimension can be drawn by taking the values of N1 and N2, 0, plus minus 1, and plus minus 2. So we can draw it directly. So this is third Brillouin zone shown by these circles. So third Brillouin zone is shown by these circles, third zone. Similarly, we can obtain the Brillouin zone in three dimension by the equation kxn1 plus kyn2 plus kzn3. This is equal to plus minus pi by a n1 square plus n2 square plus n3 square. In this, the first zone for simple cubic lattice will be a cube intersecting the kx, ky, and kz axis at pi by a. Like in this was a square, okay, and this was intersecting at pi by a, minus pi by a, plus pi by a, minus pi by a. So in this also there will be a cube, and point of intersection of the axis kx, ky, and kz will be at pi by a. Okay, and second zone is obtained by adding the pyramid to each face of the first zone cube. The first zone cube was obtained by this, and if we add a pyramid like in this we are getting a triangular form. So in this also we will add a pyramid to each face of the first zone, and we get the three-dimensional second zone. So this was all about the E versus K diagrams and Brillouin zone. Thank you.